Good morning, good afternoon, and good evening, everyone. So today we're going to be continuing a little bit of our coding. So this is more on the data science for social science. And so basically, we're going to be analyzing some data on the BES survey data to see how much support there was for Brexit a few weeks before the referendum occurred. So okay, let me just type it out. So we're going to analyze basically data from the BES survey, right? Okay, now you might be wondering what in the world is BES survey data? So just to give context, basically, okay, let me just, yeah, I just learned about this. Don't worry. So the context is that, okay, here's the context. So the topic that I'm learning right now on data science for social science is this idea of doing survey research to infer population characteristics. So how do we infer the characteristics of our target population? Well, we want to do some survey research, right? So just to give context here, we have we're going to be okay. We're going to analyze data. So we're going to analyze data on or from and about the 2016. Oops, oh, I'm switching tabs. The 2016 British referendum on, oh goodness, on European, I don't know why that keeps happening. Okay, let me just, yeah, somehow my computer is buggy for some reason. I don't know why. Okay, so we're going to analyze data from and about 2016 British referendum on European Union membership. Now, what in the world did I just say? Let me break it down. In simplest terms, basically, so we have British voters, right? And they were, or all of them were asked to weigh in or to make a decision on whether UK should stay or leave EU, right? So it was also known as the British exit, or in other words, Brexit. I think this was a true story, if I'm not mistaken. And so we have a bunch of researchers who they're from the British election study, or we call them BES. That's where the BES stands for. And they conducted a large survey, basically to measure the public opinion and predict the outcome. If whether UK will stay or leave EU, right? And so, okay, I keep on saying we're going to analyze data. But basically, yeah, we're going to analyze data to measure the support from Brexit and determine the demographic makeup of Brexit supporters. So, what is it about these Brexit supporters that are pro in letting them, I guess, stay or leave? right? In this case, I think leave because it's British exit, so Brexit. They want British people to leave EU. I think that's what it's telling me. Okay, so yeah, let's actually just hop right into it. So, okay, we're going to analyze BES survey data to see how much support there was for Brexit a few weeks before the referendum occurred. Okay, so we're going to analyze BES survey data, see how much supported British exit, Brexit, few weeks before referendum occurred. So it's more like a predicting of outcome, right? And so, okay, let me just type this in. So the survey was conducted between April 14 and May 16, 2016. And referendum took place, so took place on June 23. So it's literally about a month ago when this survey was conducted before the referendum. So I think the idea here was to basically predict who will prevail or who will win in terms of whether the British were or whether UK will stay or leave EU based on the data of the population. So they were kind of already predicting what was going to happen based on the population, right? And this is a really cool study. I mean, we can do this everywhere, say for elections, right? Given the demographics of this particular population, we get some sample and then we check, okay, maybe they're pro this guy, right? They're pro this guy or this woman, right? Depends. They're pro person, right? Anyway, I'm not a social science guy, so I don't know. But this is an interesting study we can do, more of predicting based on demographics of a population. And we do that through data science. Okay. Right. So let's just go over, or actually, let me just load in the data because I think I have them in the same directory. So the way I would load it, we just do BES, right? Do an assignment operator. We read the CSV file, and then we put in the CSV file. And we just look at the head. Let's see what that looks like. Right, so here we can see 6 observations because I just did head. But here we can see four variables, mainly vote, leave, education, and age. So this guy or this person voted leave, 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 stay, don't know, stay, leave. Oh, these are the same. These two columns are the same, vote and leave. They just made it 1 and 0. 1 for leave, 0 for stay. Don't know is NA. And then we have education. I wonder what those mean. So in order to really understand what each of these variables mean, when we're doing data science, we need to have some sort of data dictionary where it tells us what exactly do each of these variables mean. So I'm going to do that right now. I'm going to say data dictionary. And so the first variable we see is vote. Now, what does vote mean? Basically, it's the respondent's vote intuition or intention. My bad. Right? In the EU referendum. So mainly these are in the words of leave, or these have words leave, stay, don't know, and among others. Won't vote is another thing, right? Actually, there was a better way we could have read this data set. At least in R, I think it's way easier. We could have just done this, and it will show us everything. Yeah. So these are all the data. Oh, it's quite long actually. Yeah, it's 30,000. Okay. Yeah, we could have coded that one. Right. So that's the vote variable. Next, we look at the lead variable, which I personally think it's kind of the same as vote. So identifies what this variable entails is it identifies leave voters. And we can say one meaning intends to vote leave, and then zero meaning intends to vote stay, right? And then we have a couple more. We have NA, so that's either don't know or won't vote. So these are more of, not really sure what you call them. I don't want to say outliers because they're probably not outliers. Or won't vote. Okay. Right. We have two more. Education. We so yeah, when I looked at education, I was confused what that was. There was 35424. So to characterize this, this is basically a numeric non-binary variable. And the way to interpret that is it's basically the respondent's highest education qualification. And so what does that mean? It means that one is no qualifications, two is general certificate. So I'm assuming the bigger the number, the highest of secondary. Three is general certificate of education advanced level. Okay. Four, undergrad degree. Five, postgrad degree. NA is no answer. Not that that's what it means. Actually, that's probably what it means. No answer. Right? And the last one, I think this is pretty self-explanatory. It's the age, which is just the respondent's age. There's really nothing more to say to that in years, to be specific. Cool. So now that we have our data dictionary, so we can interpret the data now. Let's actually try to do some analyses here. But before we actually start, we need to load and make sense of it, right? So just as we did in the previous chapters where we've been loading data sets, or I think it was only one. Yeah, I did load one data set. So, okay. Okay, again, let's just look at the first observations here just to get a feel of what the data is telling us. So first observation tells us that this respondent voted leave. So leave is one. And this person has a general certificate of education advanced level, and they are 60 years old. So that's how we interpret that first observation or first row. Okay. Right. So based on this output and table, including the title of the table, we learned that each observation represents a survey respondent, right? And that the dataset contains 4 variables. And so, hmm, what's this? Call the FL switch. Date? Oh, that's fine. I don't need to know that. Right. So putting it all together, for example, we interpret the first observation as representing a survey respondent who intended to vote leave in the EU referendum and was therefore a Brexit supporter whose highest educational qualification was the General Certificate of Education Advanced Level. So that's the British equivalent of a high school diploma, and who was 60 years old at the time of the survey. Okay, so let's determine how many respondents were part of the survey. So to do that, again, we write some code, we do dim, and then we do best. And this will tell us how many rows there are and how many variables we have per columns in this case. So here we can see we have 30,000, around 39,000 observations, and we have 4 variables. Okay. Now, based on this output, we determine the dataset, it contains 30,895 respondents. So the sample size N is 30,895. That is the biggest. Yeah. We assume already that the survey has been the sample from the survey has been taken, right? That's the assumption. So, okay, let me just write this out. Mhm. So we say dataset contains 30,895 respondents. So sample size N is equal to 30,895, right? Okay, now let's actually try to predict the referendum outcome. Are the UK people going to go out of EU or they're not? How do we predict that? Well, we look at the demographics, right? So we estimate the proportions of eligible UK voters who were in favor of Brexit and opposed up to Brexit at the time the survey was conducted. So hopefully, if the sample of respondents in the BES survey is representative of all eligible UK voters, then we can use the proportion of individuals' characteristics in the sample as good approximations of the proportion of individuals' characteristics in the entire population. So the idea here is that this is the data that we got is actually not the whole population. It's just a sample of the whole target population. And we're hoping, or at least here we assume, that this data or the sample from this data is representative of the target population. And so that means it can give us a good approximation of the characteristics of the individuals in the target population, right? Okay, so to compute the proportions of individuals who were in favor of and opposed to Brexit in the BES sample, we create a table of proportions of the variable vote. But first, we need to create a table of its frequencies. Okay? Okay, so let me just briefly go to my notes. I hope this will show. Okay, so let's talk a bit about frequency. Frequency tables. So this is basically, no, it's not basically. The frequency table of a variable shows the values of the variable takes and the number of times each value appears in the variable. Okay, I don't know what that means. So let's say we have this x and it has these numbers 10010. So two ones, three zeros. So the frequency table of x is the following. So we have our values and we have how frequent these values appear. So here we have values 1 and 0, right? Or 0 and 1. We have two ones and three zeros. That's basically what a frequency table does. So what that table shows us is that x contains three observations that take the value of 0 and two observations that take the value of 1. Right, so let's actually go back to R and let's do one. Let's do a frequency table. So again, you predict the referendum outcome of whether UK people will stay or not. Well, we have to, okay, assuming sample is representative of target population, the assumption, right? We now compute portions of individuals, characteristics in the entire target population. Okay, so let's actually do a frequency. Oh shoot, I put Python. Let's do a frequency table here, right? So the way we're gonna do this is we're gonna use a function called table, and the only required argument is the code identifying the variable to be summarized, right? So in this case, if we want to calculate, say, do table, we do our data, so we just need one variable. We're gonna do vote, right? Do you wanna determine how many said leave, how many said stay, how many said don't know, how many said won't vote? Here we see a couple of people who said don't know, leave, stay, won't vote, right? So just to interpret what this is, I think it's pretty self-explanatory. 1,000 respondents are undecided, right? 13,693, 692 intended to vote leave, that the British people leave. 14,352 intended to vote stay, and 537 won't vote. So that's how we interpret that. I think it will look nicer if we do it this way. Cool. Okay, so that's how we interpret that. Now, the way we check if this works is, well, we want to total them, right? So if we total them, we can just use a calculator to be honest. All of these, it should be 30,895. Then we know we got all of the respondents. That's the total sample size. Okay, so that's what we call a frequency table, right? Okay, let's go back to my notebook. So if we have frequency tables, we also need what we call tables of proportions. So you can kind of already get an idea of what this is. Basically, we do this, it's the same for frequency tables, but we do it using percentages. So say again, we go back to that example. We have X, and then we have a bunch of ones and zeros. So our table of proportion is the following. Proportion. It's the following. We have values 0, 1. So values are 0, 0.6 and 1 is 0.4. How do we know? We just divide them. So the total of the total numbers here are 5. 1, 2, 3, 4, 5. How many ones do we have? We have 2. So this is 2 divided by 5, which is 0.4. If I'm not mistaken, then 4. Yeah, 0.4. Similarly, for the 3 zeros, that's 3 out of 5 observations. So that's 0.6, right? Or 60% if we multiply it by 100. Cool. So that's table of proportions. Now going back to our code here. So that table shows that again, 60% of observations in X take the value of 0 and 40% take the value of 1. Now recall to interpret a proportion as a percentage, we multiply the decimal value by 100. So to create a table of proportions in R, we use the function prop.table, which basically means proportion, proportion, which converts a frequency table into a table of proportions. And now this function takes as its main argument either A, the name of the object containing the output of the function table, or B, the function table directly. But in both cases, the variable of interest is specified inside the parenthesis of table in our current example. Okay. So the way we want to do this is first we have to create again that table, right? So I could have just copy pasted. So initially we have this frequency table, and then what we want to do is assign that to some variable. This is not too important, but it works. And then we can do prop table, frequency table. And this will give us the percentage of each. That's one way of doing it. Another way is we could do pipes, right? So another way we could do it, and I'll just leave this here. You could do a pipe, put it first in the table function. We do a pipe again, and then we put it in the prop table. And that will give us, oh, funny. Table, not find, oh, interesting. Couldn't find this guy. Pretty sure we just did it in the last video. Where did I mess up? Hmm, hopefully I didn't. If I Funny. Find it. What if I do very basic example? What will this output? A 4, right? Okay. So this 4, we want to pipe it to the square root function. So we should get to. Ah, okay. So it's not my error. It literally cannot find this thing. Okay. Let me just open this. 'Cause I was able to do it. Or oh, it was lab 4. I forgot. Yeah. It's the same. What? Or the library. Oh, I don't have dplyr, that's why. Okay, my bad. Oops. Yeah, so another way we want to do this, so I needed the dplyr library. I almost forgot about that. Because this is a dplyr pipe. Let's run that. And nice, worked. That's why it couldn't find this thing. So again, if we do the same thing, but we do a pipe, and now hopefully it should read it. Do a table here, do a pipe again, we do prop table, and we're done. There we go. So we could do it both ways. So this one's using the dplyr pipe. And I think this is more organized, especially when we're doing nested functions. It's also good to store them in variables. At least that's the coding practice I personally like. But doing it with pipes is also pretty cool, just to avoid nesting. So it's either storing it in variables or using this pipe. Any works, but it's really up to you. Okay, so right, enough of the coding styles. So let's get back to the analysis. So based on the proportions in the samples shown in the outputs above, right, we can estimate that when the survey was administered. Okay, let's actually interpret this thing. So we can say that okay, when the survey was administered, so we can say that around 44% of eligible voters in the UK or UK voters. Oh wait, am I sharing the right screen? Oh, I was sharing the textbook the whole time. That wasn't nice. Okay, so here I just did a proportion table, right? And now am I sharing the right screen? Okay, I did a proportion table. You could do it two different ways. You could use a pipe to do it. And you have this don't know leave stay in proportion. And to get their percentage, you just multiply it by 100. Okay, so here we see that leave has around 44.32% if we round it off to 2. So they intended, so 44% intended vote leave, right? That's what we see in the data. And 46% intended to vote stay. Okay. And here we say that more than 7% of the population was still undecided. It's really a nice way to gather data using this. Pretty cool. At this time, Then a slightly higher proportion of respondents intended to vote stay rather than leave. The proportion of undecided, however, was larger than this difference, 7% greater than 46 to minus 44. Hmm. So even though a slightly higher proportion of respondents intended to vote stay rather than leave, here's the even though a slightly higher proportion voted stay than leave, well, the proportion is still undecided. Oh, the proportion of undecided was larger than the difference. So what I'm saying is that 7% is greater than 46% minus 44%. So that means the survey results did not provide a clear prediction of the referendum. So apparently, we have more undecided people than the difference between stay and leave. So it's not a clear prediction. We cannot predict this basically. But in reality, the referendum turned out to be quite close, right? The leave camp received 51.9% of the vote, and the stay camp received 48.1% of the vote. Thus, the leave camp won with a margin of only 3.8 I think this is real life. 3.8 percentage points. Yeah. Okay, so that's it for this video. I'm gonna take a little bit of a break, but I hope you guys enjoyed and learned something from this at least. I think it was pretty fun doing this, and I'll see you all in the next video.